to talk about the homework.
Yeah, I must have because I forgot that.
Alrighty. So today, I had told you the more complicated piece than A is talking about the horizontal, the B value here, which, yeah, they're using different letters for it than we have in the past, but the B value here is going to be the horizontal compressions or stretches. And so it's a good place to start after you've already done some with a change in A. And this tells us that A sine of B, once it's factored out of x minus h, is going to give us a nice form to use. And of course, we're going to slap a plus k on there at the end. And just going to make sure we have all the horizontal shifts, which are going to be called phase shifts. They have special names with trig functions. But k is still just a vertical shift. That's all it is. So the period or length of one cycle can change to be longer or shorter than 2 pi, dependent on that little b value. So if the absolute value of b is greater than 1, we have to think backwards because this is dealing with x. If it's greater than 1, we're actually going to get a shorter period. It's going to be that horizontal compression. And if the absolute value of b is less than 1, which is going to be a fraction for us to take a peek at, we actually have to think backwards and say, hey, this is going to be a horizontal stretch for this. So the absolute value of b is the number of cycles in 2 pi, which means how many of those repetitive cut and paste pieces we're going to see in that 2 pi. And that little formula is something we want to memorize, and that's just 2 pi over the absolute value of b, bless you. Because remember, the b value is what's going to change that horizontal stretch or compression. A negative there tells us something different. A negative there tells us we're going to reflect over the y-axis. So that's why that absolute value piece is there. So to graph the sinusoid using the new period 2 pi over the absolute value of b, then what we're going to do is divide that into 4 equal parts. And if that seems weird, what's up with the 4 equal parts? I want you to think about how we graphed yesterday with axis high, axis low, axis. And yes, I lined all of those up because here's what I need you to see. We have 1, 2, 3, 4 pieces that's been broken into. And those will always be the same length. So that's the reason that we break these into 4 equal parts. And then like it says, we'll just use Kahala. If you use the mnemonic device, you do. If you don't, that's okay. But you have to be able to figure out how to graph that piece. So this says we're going to determine the period for each equation and then graph 2 full periods. And a lot of what we're going to do today is just focused on this. If we change a number in here, what happens? So to start with, we'd say to ourselves, this is sine. Sine is normally 2 pi. But this one has a b value. There is a 2 in front of here. So I start thinking, okay, but it's the x. So if that's a 2, it actually means we're going to horizontally shrink this bugger by 1/2. So I'm just kind of getting a feel for the graph before I do anything. And that absolute value of b in this case is going to be a 2. So this is telling us that the cycle here is not 2 pi anymore. It's 1 pi. It's 1 pi. Now, there's another way to get that that's going to be helpful once we have a lot of things going on. And that way is to always set it up as the normal period for sine and cosine, which would be from 0 to 2 pi. But that's been changed because there's something up there with the x value. So we go ahead and put the 2x in here, and what we would do is we would just solve for x. So we would say, hey, we're going to divide everything by 2, and it's still going to start at 0 because 0 divided by 2 is just 0. But now we can see, yeah, it's going to go from 0 to pi. That's what's going to happen. So sometimes they'll just ask us for the period, and if that's the case and we don't have to do any graphing, then 2 pi over the absolute value of b is great for that. But if we're going to do the graphing, we really want to know where are we starting, where are we stopping, and that gives us an idea of what we have to use for our intervals. So I started thinking, I want to break this into 4 equal parts. From 0 to pi, that's pi. I need 1/4 of that to get 4 equal parts. And those equal parts are called increments. Increments. because of all the nice symmetry that takes place with sine and cosine. If we have those, then we can just think our way through what points we're going to use. Well, a fourth of pi is pi over 4. So I'm starting with 0, and I'm going to keep adding pi over 4 until I get to pi. And if I don't land at pi, I know I did something wrong because I said 1/4 of this was supposed to be 1/4 pi. So 0 plus 1/4 pi, or pi over 4, will give us pi over 4. So this will be the starting place for our graph, but this will be the next place that we want labeled on our graph. And then if we take our pi over 4 and we add another pi over 4, well, now we're going to have 2 pi over 4, which will give us a label of pi over 2 for that next increment. I need one more, and then hopefully I'll land at pi. So I add another pi over 4. Pi over 2 was really 2 pi over 4. 2 pi over 4 plus 1 pi over 4 is 3 pi over 4. There's another increment, and now I want to make sure that it's actually going to land at pi, so I know I didn't make a mistake. So 3 pi over 4 plus 1 pi over 4 is really good news, because that's pi. So those are the labels that I want. I've got my beginning and my end, and then 3 things for the middle to break it up into 4 equal pieces. And those are my increments. That tells me how I need to label this. You know, when we did the normal sine and cosine with just an amplitude change yesterday, we were always using 0, pi over 2, 1 pi, 3 pi over 2, and 2 pi. Because this has changed, because we have a number in front of the x, now we have different increments. So what we want to do is make sure that we can follow the directions which say that we should graph at least 2 full periods. But if we do one on the positive side and one on the negative side, we'll have that anyway. So I look at my increments and I realize obviously I'm going to need a label of 0 on here. And then I need a pi over 4, and I'll go 2 because I like to spread this out so everybody in the back of the room can see what I'm doing. Pi over 4. And then our next one was pi over 2. And then we had our 3 pi over 4. And our 1 pi down here at the bottom. We're also going to want to go backwards so we can get 2 full periods. So we'll just change those to negatives. And then I focus on my y-axis. Well, my amplitude's 1. It's still going to be up and down 1. So it's up to you if you want to space it out or if you want to just use 1 and -1 here. But either way, you have to label it. You know, so if somebody looks at it, they're going to know. And again, I'm going to spread mine out a little bit so that it's a little easier to make out sitting where you guys are. Now, this is sine. We know sine starts at 0. So that's where we're going to start. 0, 0. And we know sine is axis, high, axis, low, axis. So sine, axis, high, axis, low, axis. And then just continue the pattern so that you have one more full period on the left-hand side of the y-axis. Does this make sense? I mean, there was a 2 up there, and that 2 tells me that my period is now just 1 pi. So if I cut and paste this, physically move it over here, will that be the whole graph? Yeah. So you just want to double check when you're done. Did I do all the things that I was supposed to do to get what I needed? So, as you can see, we've got the A and the B part. There's going to be more parts coming. So we need to get this B business down really well, which means we're doing some more of these. Definitely doing some more of these. So determine the period for each equation, then graph 2 full periods. Okay, they want the period. That's not a big deal. I'm going to need to know that anyway. So 2 pi over 4 is going to give me pi over 2. Huh. So we've gone from 2 pi down to pi over 2. Does that make sense with the number they have up there? Yeah, because it's a 4. And remember, a 4 in front of the x means we're actually going to horizontally shrink this to a fourth of its size. Pi over 2 would be a fourth of that. So now I do it this way and say, you know what, for graphing purposes, I know that cosine is still 0 to 2 pi for the period. But now I have this 4x in here. Divide everything by 4. You shouldn't be shocked that we get the same thing. But what that usually does is it helps people start thinking, okay, I'm going from 0 to pi over 2. I need 4 increments. So I'm going to need a fourth of that pi over 2. And that means we're going in eighths. Pi over 8. So if I have to use pi over 8 for each one, I think, okay, well, I'm starting at 0, and then I'm going to get pi over 8 because I add 1 pi over 8. But now I've got to add another pi over 8. So 1 pi over 8 plus another pi over 8 will be 2 pi over 8, which we would reduce to pi over 4. All right, so we've got 1 pi over 8, 2 pi over 8, 3 pi over 8. There's no reducing we can do there. Pi over 8. That tells us we chose our increments right. Because it ends up being pi over 2. So that's what we need. So now we want to space these out so that we have room enough to show everything. And again, I'm going to go by 2s. That will give us 1 period of our graph. But we should go back the other way as well. So we can follow directions. Like so. Look at your A value. What is it? What's your A value? 1. So our range, again, I'm just going to space mine out so that it's a little easier to see, but you wouldn't have to. We're going up 1 and down 1. But this is cosine. Kahala. Cosine starts high axis, low axis, high. Nice smooth curve. And you realize, yeah, that's 1 period, that's working. From 0 to pi over 2, we can cut and paste. Work that backwards. And we have 2 full periods. So there it is. Changing those increments is huge. And the rest of this is just what we did yesterday. But we change those increments and we have to label them so people know, hey, this is a different graph than what we would normally see if we just graphed cosine. All right. A and B at once. Oh. Well, you just have to kind of keep track of it. You know, once we get everything labeled, things are going to work out fine because we're going to think about A when we go to label our Y's. And that's kind of the last thing we should be thinking about when we get there is, wait a minute, am I going up 1 and down 1 or where am I going? So we're going to look at A and B. And And that A part again gives us our new range, and the B is now changing those increments. So determine the amplitude and period for each equation and graph two full periods. What's A? 3. So already in my head, I'm seeing up 3 and down 3. Now this is definitely going to be a vertical stretch here. The 2x part, well, we just saw that in the other one, but we take a second and say, okay, that's going to be this again. So that's going to give us 1 pi for the period. One of you can sleep and have another. That's not fair. You should shout about that. So we've got our pi. Again, if they don't ask us for the period when you're graphing at home and doing your homework, it's easier to just think, okay, sine is usually to 2 pi. I'm going to throw my 2x in here and divide everything. Again, you get the same thing, but it just some way visually helps people more with figuring out, okay, this is what I'm going to have to use for increments. Because from 0 to pi, how are we going to break that? What do we do for the increments? Where are we looking for our increments if we're going from 0 to pi? How many pieces do we break it into, everybody? 4. So we're going to take this pi minus 0 and we get pi. And we know we're starting at 0 and then we have pi over 4. And we say, okay, well that's 1 pi over 4. If I add another pi over 4, I'm going to have 2 pi over 4. But that's pi over 2 when it's reduced. I add another one, now I've got 3 pi over 4. I add one more, I'm at pi. That's a big deal, by the way, because if you did accidentally mess up on one of the increments, you could check it right there and say, oh, I got to pi. That's exactly what I needed to do. So here's our labels for our increments. We're going to need the 0. We're going to need pi over 4, pi over 2, 3 pi over 4, and pi, and also the negatives. Now, like I said, we haven't had to think a whole lot about the range before because our A value was 1. But this is the kind of the step you need right before you start graphing anyway, is to remember, oh, wait a minute, I gotta go to 3 this time. 1, 2, 3, 1, 2, 3. Label those so you remember, hey, I'm gonna go up here. Notice I didn't even put the 1 and the 2 on there. And that's just because I want to focus on the fact that this is going to go to 3. You could always go back and put those on later. All right. Sine. Where does sine start? Right there at the origin. 0, 0. All right, so we're right here. Now what do we have to be careful of as we go to pi over 4? Up 3, exactly. So sine, Sahala, sine, axis, high, axis, low, axis. And usually if you mess up on the second one and you don't go all the way down to -3, when you start graphing it, you go, oh my gosh, I can't believe I didn't go down all that way. You get it. And then use the pattern backwards. Here's our amplitude and here's our period like they asked for. And we graph full periods. So far so good? Okay. A and B again. A little bit different. I want to think about what this is going to do. We've got a 2 out in front here, which means this is going to be a vertical stretch. We've got that part down, but a 1/2 in front of that. So in front of the x. So what does that really mean it's gonna do? It's the opposite of what we think. This is actually going to be a horizontal stretch factor of 2. So we should see a longer period this time. So amplitude is 2. Period, going to be 2 pi over b. Absolute value of 1/2. Well, we don't divide by fractions, we multiply by the reciprocal. And here's where we see that longer period, because we're doubling. We're making it twice as long with that 1/2. X's are always opposite. Well, that's not hard to break into increments. Once we see it like this, what's the length of our increments? 1 pi, yeah, because 4 pi times 1/4 is 1 pi. So we're going to have 0, pi, 2 pi, 3 pi, 4 pi. Like that one. All right, so let's get that labeled on there. Now let's talk about the range, the y's. Where are we going this time? Up and down 2? Where do we start this graph? We need coordinates for the starting place. 0, 2. Yeah, cosine, remember, Kahala. Cosine is high, axis, low, axis, high. Use the pattern backwards. Feeling really comfortable with this? 4, 3, 2, 1, 0 me right now. If this was all we were ever going to learn about cosine and sine, where's everybody going? Yeah, I noticed a lot of people are heads down doing what we need to do. Excellent. We know this isn't it though, by the way. We haven't covered H and K yet. So we're going to have to get used to this as the shape of the graph and then start shifting things one way or the other. So down here, we're going to talk about the fact that there are different names for it because the study of sound has been around for a long time. The frequency of a sinusoid in this big mess that we see right here is the absolute value b over 2 pi. And if you're thinking, wait a minute, isn't that just the reciprocal of the period? You are absolutely right. It is just the reciprocal of the period. The frequency, think of sound waves. The frequency is where we tune our channel into. So that frequency is incredibly important. We have to be able to find that. So the frequency of a sinusoid, we're going to use absolute value b over 2 pi. Same thing if we're talking about cosine. So if we need frequency, that's what we're going to do. Graphically, the frequency is the number of complete cycles the wave makes in one unit interval. So how many complete cycles of the wave can occur when you're using one unit interval? So down here it says we're going to figure out the frequency of a sinusoid. And literally I always think of this as it's the period upside down. So it was 2 pi over b, now it's going to be b over 2 pi. That's what we're looking for. So that means I need to know what b is. B is supposed to be factored away from that x. Well, it's not a big deal here. This is just 2/3 x. So we know that the b is 2/3. And the absolute value of 2/3 is just 2/3. So what do we do with that? Well, we want to actually do math and see what happens. So fractions, we don't divide, we multiply by the reciprocal. Well, the 2's are going to cancel out. So this tells us every unit interval, we will see 3 pi of this. And let me see, the fancy language here was 1 full cycle for an interval of length 3 pi. The one on the top tells us, hey, this is a full cycle. And then what we get on the bottom tells us the interval to make that happen for frequency. All right, so let's look at this one. What's B in this one? 3. Okay, absolute value of 3 is 3. But I'm supposed to get it to look like this. So I can say 1 full cycle in blah, blah, blah. Do what? You're kind of thinking right. You're just a little short. Divide by 3. Here's why. We've got a 3 on the top and we want it to be a 1. So we're going to divide by 3. Here's another way to think of it. Remember, when we work with fractions and we're doing division, we always multiply by the reciprocal, right? So if we need to get rid of this, wouldn't that do it? Yeah, because it'll flip it over. It'll flip it over. And yes, it is. It's division. I mean, that's what we're doing here. We're dividing. So now we know that we can tell them this will be 1 full cycle for an interval of length 2 pi over 3. Actually, don't use this a whole lot. I mean, there might be like one test question or something where they ask us for frequency. We just don't, and that's because for the math part, frequency is not a big deal to us. Obviously in sound, frequency is huge, but for the math part, all it does really is explain what we already know about the period. You know, that's really all it does. Alrighty, next up, phase shifts. Yeah, phase shifts are the name that we give to horizontal shifts with sinusoids. And that's because, again, they've been around for so long and they've been studied for so long, they already had a special name, phase shifts. So you look at this and it says getting one sinusoid from another by a phase shift. Oh, well, that doesn't look too hard, because if I just take this one, actually let me do this. If I take this one, and I slide it over, I have the other one. So it's just a question of how far did I slide it over? Well, it was here, and now it's here. I slid it over pi over 2. So, oh, come on, grab the right one. There we go. If I'm starting with cosine and I want to know what to do with it to get sine, I'd say, well, I had to move it over pi over 2 to the right. And because x's are always the opposite, and the x's are what we're moving here, it would be x minus pi over 2. So you have to think about which one you want and which way you're going to have to do your shifting in order to make this happen. And usually they'll tell you exactly what they want when you're doing the problem. So sine and cosine are complementary functions. Again, those are cofunctions. You know, they're angles that add up to 90 degrees, and that's why they have that special relationship. And they only differ by a phase shift of pi over 2, or 90 degrees. So it says, write the cosine function as a phase shift of the sine function. Okay? Oh, it took it off. I don't know what this big B showed up for. There we go. All right, so with this one, what they're saying is, what we're supposed to do is figure out cosine as a phase shift of the sine function. So cosine of x equals something sine. So here's my sine function. Here's my cosine function. Think about the shift, about which way this is going to have to go. Well, if I want sine to match up with cosine, I've got to move it back. This way. How far has it moved? Pi over 2 again. And this time I had to move it to the left. Remember, they're always opposite. So it's going to be x plus pi over 2 for that phase shift. And I wanted you to be able to see that, so I know I wrote that in the wrong spot. I wanted a visual along with it. Write the sine function as a phase shift of the cosine function. So they reversed it. So if we had to go to the left to get this one, which way are we going to get the other one? To the right, yeah. So it'll be a x minus. So sine of x equals cosine of x minus pi over 2. And again, that's called a phase shift. In the past, we've talked about the horizontal shift that we've gone through there. So that's what h is for in everything that we're doing. So the phase shift is horizontal shift. It just has a fancy name, that's all. The phase shift is a horizontal translation of the graph along the x-axis. But in your homework, they're not going to ask you for the horizontal translation. They're going to ask you for the phase shift. So we need to know that language. If it's positive, shift left. Again, anything with the x is backwards. It behaves backwards. If negative, shift to the right. To find the new period and 5 critical points, this gets a little tougher to do. What we want to do is follow these steps. And this is what I was talking to you about before. When you're graphing, what you want to do is say, okay, anything that's behind this, that's part of the x pieces, which would be the b and the h, I want to use that along with a compound inequality to figure out, what are my new positions here. So this one says we're going to find the new period, the new starting point, and the 4 critical points to graph 3 times the sine of x minus pi over 2. So let's start with the period. What's b in this one? It is 1. Yeah, if there's nothing there, it's a 1. So it is 1. So we're still going to get 2 pi for our period. However, this one is not starting at 0, 0. What is the x value that this will be starting at? Pi over 2. So here's what's just happened. Our graph that used to start at 0, 0. Before we can start it, we got to move it over and then figure out how far to go. So like I said, this helps us figure out where are we starting, where are we ending, and then how do we get those pieces that we need. So this will be adding pi over 2 to every piece. So you think, okay, 2 pi, I've got to add pi over 2. 2 pi is 4 pi over 2. So I'm going to be ending at 5 pi over 2 this time. Well, I want 4 equally spaced increments. So this is a little tougher. How do I get them? Well, I'm going to subtract, and then I'm going to find fourths, because fourths are what I need. So 5 pi over 2 minus pi over 2, it doesn't shock us that that's going to be 2 pi. So I've got to take 2 pi and divide that into 4 equal pieces. 2 pi divided into 4 equal pieces would give me what? So here's what I know. I'm absolutely gonna start at pi over 2. And to get to the next place that I need to be, I'm going to have to keep adding pi over 2, because that's how long my increments have to be. So there's my first point for my x's. Pi over 2 plus 1 pi over 2 will give us 2 pi over 2. But we have to keep adding pi over 2. So 2 pi over 2 plus 1 pi over 2 will be 3 pi over 2. Three pi over 2 plus 1 pi over 2 will be 4 pi over 2, which will be 2 pi. Add one more equally spaced pi over 2. And we're at 5 pi over 2. So these would be the new places where we start our graph and use either, if this was sine, it would be Sahala. Yep, it was sine. Sahala to get there. So it would be one additional thing that we would have to think about. Now they don't want us to graph this one yet. What they wanted us to do was to find those new steps. So now, I write way too big. This one says combining a phase shift with a period change. We're going to write the function. Construct a sinusoid with a period of pi over 5. So right away I start thinking, that's going to help me find b, which is something I need if I'm going to write the equation for this graph. Okay, that's a proportion. We cross multiply. What does b have to be? It has to be 10. Has to be. It's got an amplitude of 6. But it goes through the point 2, 0. That means they're giving us a new starting place. So that's a phase shift. All right, construct a sinusoid that does all of this stuff. Okay, so y equals a, comes first, sine. Then there's b. If it's going from 0, 0 to 2, 0, is it moving right or left? Moving right. So that means it's going to have to be x minus 2. And usually we won't leave it like that. Usually we'll go ahead and distribute the 10. Sometimes your book leaves it. But usually we want to see it all put together. That's usually how we get them when we're supposed to graph them. We have to factor out the 10 and then keep going from there. All right, I've got to be getting close, right? Oh, goodness, yes. Okay, so you will be able to finish the first day's assignment, and I will uncover the second one, knowing you're probably not going to be able to finish the whole thing because we didn't actually do any of the full graphing with the change in the increments. And if you look at the next page, you're going to see we're going to do lots of that starting next Tuesday. So putting it all together, you know, the next page is filled with our new increments. And then after that, we still have to do the vertical translation. So we'll finally have all of the A, B, and H, and K put together at that point. So, whew, it's a lot of material. Thanks for hanging in there. That takes a while to get all of that done. And because of the Pep Fest, I think we had discussed going 4 days on this section. You know, it doesn't seem like a big deal to have that little piece cut off, but when there's so many people gone during these days, and it's really, really hard. So we'll probably end up going 4 days on this section just to make sure everybody's caught up with what they need.